Okay, for question 1b, calculate the moduli of vectors w, z, and zw. So first, when we look at w, the modulus of vector w is a squared plus b squared under the radical, or the square root of a squared plus b squared. The modulus of vector z is the square root of c squared plus d squared. When we think of ZW, we calculated the square root of AC minus BD quantity squared plus AD plus BC quantity squared. Now, what we want to do is expand these squares. So when you expand something that you're squaring, you write it twice. So AC minus BD quantity squared. Notice this is all under the radical. And I'm going to bring the radical back in a minute. I just don't want to put all this under the radical and junk it up. So this is like a mid-step that I'm writing out, and then I'll bring the radical in once I've expanded it. So I write it twice, then I distribute. AC times AC is AC squared. AC times negative BD is AC BD with the negative in front. Now I distribute negative BD, and I get the same thing again. And when I distribute a negative times a negative, I get a positive. So it's plus BD squared. Finally, I combine like terms, bring down the AC squared, bring down the BD squared, and combine what's in the middle. So I get AC quantity squared minus 2 times AC BD plus BD quantity squared. So now I'm going to do the same exact thing with AD plus BC. I know this is a lot of algebra, and that's why I'm just showing you this in a video rather than having you do it yourself. So if you need to watch it a second time, you can, but you really need to know where this idea comes from because we're building something here. So I'm going to write AD plus BC twice. Now we distribute the same way again. AD times AD gives us the AD squared. BC times BC gives us BC squared. But in the middle, we've got BC times AD, which is also AD times BC. When we do it again, AD times BC one more time, and then we combine like terms. Bring down your AD squared, bring down your BC squared, and notice we've got two of those middle terms again. Now we're going to take all this and clean it up. So what I want to do is just distribute my square. So AC squared is really A squared times C squared. When I distribute the negative 2, I'm just going to put all these in alphabetical order. A, B, C, D. And finally, B squared, D squared. So I took this and just brought it down. Now I'm going to combine it with this, because remember, in the beginning, both of these expressions were under the same radical. So again, A squared times D, AD squared, A squared, D squared, plus ABCD, so 2ABCD, and finally, B squared, C squared. Now, one thing I'm hoping you'll notice is that we've got a negative 2 ABCD and a positive 2 ABCD. So those can just cancel each other out, and so we take them out. Now we have our A squared C squared plus B squared D squared plus A squared D squared plus B squared C squared. And again, it's a lot. I get it. All we want to do is clean it up. This is the mindful manipulation part where I move things around a little bit, to make it do what I want to do. Because as mathematicians, that's our power. We can change things, manipulate them so that we can clean it up and get rid of some of the junk. So if you notice, I've got an a squared here, and I've got another a squared over here. So I want to move these two middle terms so that I get the a's together. When I do that, I've got the a's on the left. So here's an A and here's an A. And then I've got the B's on the right. And what that allows me to do is factor out the A squared. When I factor out the A squared, I'm not getting rid of it. I'm putting it outside the parentheses, right? I'm left with C squared plus D squared. And interestingly enough, on this side, when I factor out the B squared, I'm left with the same exact thing, C squared plus D squared. And of course, now I can use my distributive property to put A squared and B squared together. So I've got A squared plus B squared times the quantity C squared plus D squared. And this is the really fun part in math, when you do all this work and everything comes together in this nice, neat little package. And now the last thing I'm going to do, remember, ZW was under the radical. So I'm going to put all this under my radical. And the length vector ZW is actually the square root of A squared plus B squared times C squared plus D squared. And what that really tells me, and here's the power, is that the length of ZW is actually the modulus of W times the modulus of Z. And that works for any vector W and Z. So now what we've done is actually shown a rule that says if I want to know the modulus of a vector, if it's a product of two vectors, all I do for the modulus is just multiply the modulus of one times the modulus of the other. And that is a tremendously powerful tool that we're going to use with vectors moduli from now going